Alright, welcome back. We are going to continue what we did last time. So we're going to be writing out formulas for word problems that are given to us of reactions. So again, when we do this, we're going to start by reading it and just writing down everything that we see. So we'll start at the beginning of this one. Solid copper, so we know that that's just going to be Cu and solid, is placed into a solution of silver nitrate. So we're putting something into a solution, so we're placing it. So that's going to mean we're going to be adding it in to a solution of silver nitrate. So because silver nitrate is a compound, we need to figure out its formula. So when we figure out a formula from names, we use our charges. So silver is always going to be +1, and we know nitrate from our polyatomic ions list is NO3-. We make a formula, we're going to get AgNO3 because they're both -1. So we have AgNO3, and it says solution, and solution means it's going to be aqueous. Okay, and then we have and forms. So when we have something is being formed, that is our arrow. That is a key to put our arrow. Solid silver metal. So when silver is by itself, it's just going to be Ag. And is going to be plus. The solution of copper 2 nitrate. So again, we have to look at the charges. So copper 2, that means there's 2 plus. It does not mean there's 2 copper. It means that the copper has a 2 plus charge. And then we know nitrate. When we make our formula, we bring the 2 below the nitrate and the 1 below the copper. So it's going to be CuNO3 2. And we'll bring that down as a solution. So CuNO3 2. Ignore that dot there. That was just an accidento. And then it is a solution. So it is aqueous in solution. All right. So there is our reaction written out. So we have to determine, okay, what type of reaction this is. So for this, we have an element and a compound on both sides of the reaction. So that is going to be a single replacement reaction. In a single replacement, we just have one switch. So in this reaction, we actually have the copper and the silver switching, right? So the copper is by itself, the silver is with the nitrate, and then when we look over here, the silver is by itself and the copper is with the nitrate. So we're just having one swap. Okay, so all that's left now is to balance it. So we have copper, silver, and then we have nitrate, which is by itself. Because nitrate isn't split up, the nitrogen and the oxygen is the same as nitrate in both sides. We don't have to split them up. We can just keep them at nitrate, which is fantastic. So we'll say, okay, copper, 1 on each side, silver, 1 on each side, nitrate, 1 on the left and 2 on the right. We'll start off by balancing our nitrate right away. So we have to multiply by 2 on the bottom. That gives us 2 there. That also made us multiply our silver by 2. So that means we'll have to do that again over here. And that'll be our balanced reaction. Okay, 1 copper, 2 silver, 2 nitrate. Okay, so that's basically the extent of how hard these will be. Let's move on to the next problem. Let me make sure this is fitting on the screen. There we go. All right. Solutions of sodium chloride. So sodium chloride is a compound, so we have to start off with sodium. Na+, Cl-. It's 1 to 1, so our formula is NaCl. So we'll start off with NaCl. And it says it's a solution, so it's aqueous. And, so that's our plus, right? Silver nitrate. So we just did silver nitrate. So we know that's Ag plus, NO3 minus. That's just going to be AgNO3. So for the silver nitrate, it actually doesn't have a state of matter. But what we know from English is because it says solutions here, that is implying that it is plural, and it's going to be carrying over to whatever is said next. So it's going to also be aqueous because nothing else was said, and this is plural, so it goes to both of them. They are combined. So these two are combined together to form. So that also indicates that it's that's going to be our plus symbol, to form. So again, our form is where we put our arrow, right? A solution of sodium nitrate. So we have sodium and we have nitrate put together to make a formula is just going to be NaNO3. And this is really nice because all of the elements in this problem have a charge of +1. It's not always going to be that nice. NaNO3. And this says, again, that's a solution, so we're aqueous. And solid silver chloride precipitate. So we'll have our plus, because this says and. Silver chloride, we have AgCl. So silver's +1, chlorine's minus, so our formula is AgCl. And then it says precipitate. So precipitate means what? It means it's going to be a solid. Okay, so there's our reaction written out. We can now say, okay, what type of reaction is this? We have 2 compounds on each side. We have NaCl, AgNO3, NaNO3, AgCl. These are all compounds because they have more than one element in the formula. So this is going to be a double replacement reaction. So we'll say at the top, double replacement. All right, so now all that's left is balancing this out. So we have our sodium, we have our chlorine, we have silver, and again, we can keep nitrate by itself, not breaking up, because nitrate's the same on both sides. So now we can balance it out. Sodiums, chlorines, silver, nitrate. Already balanced. There's 1 on each side. So we're good to go. Okay, so this is for double and single replacement. There's a lot more to write, but that doesn't necessarily mean that it's harder. So it just requires you to use the knowledge we've already learned, to write out formulas, and pay attention to the states of matter. And again, use your good friend Gugale to help you if you need help at home. And don't forget, you can ask me anything in the Teams channel.